Hello everyone, my name is Alex Knittel and my product is Accent Inspector. So I set out to answer the question, can I train an algorithm to detect the accent of a speaker similar to the way that the human ear can? This has several applications in customer service and marketing. If you wanted to target certain groups of people, this would be useful for you. Also in accent reduction, if you had an accent that you were looking to reduce or eliminate. So what I did is I found a data set of over 15,000 recordings of speakers with 39 represented native languages. They were all reading the exact same transcript in English. Once I had the audio files, I needed to figure out how can I extract useful information from my analysis. This led me to a free linguistic software called Pratt. On the top of the screen, we have a Pratt waveform for the words, please call Stella. These were the first 3 words in my transcript. And on the bottom is the spectrogram, which gives us frequency information. You'll see some darker bands down there, and those are the most prominent frequencies occurring, and those are known as formants in linguistics. Here I have them labeled. So formants are very useful for determining what word is said, as well as comparing differences between different speakers. So let's say we want to analyze the second word, call, for this particular speaker. All we need to do is measure the formant values. There's the first one, another one there, and there. The next thing I did is use a pulse analysis to determine where the vowel sounds were occurring, and I partitioned the formant data based on the location of those pulses. Here I've plotted the mean formant 1 and formant 2 values for the aw sound from that word call from before. And as you can see, there's a lot of overlap. The differences are very subtle here. Zooming out, now we're looking at 6 vowel sounds for 3 different accent classes. And let's say we want to draw the decision boundary for the Afro-Asiatic class. So it's going to look something like this. So due to the complexity and the high dimensionality of the space I was working in, I decided to use an SVM with an RBF kernel to make my classifications. So I trained and tuned that model, and I achieved very good results when comparing native English speakers with Afro-Asiatic and Sino-Tibetan speakers. The accuracy on those predictions was 87%. I also achieved a 90% F1 score. Now the model didn't do quite as well when I included other Indo-European accents. That's because those are more similar to English. That could be overcome by greatly increasing the size of the data set. I was limited by the amount of data that I had, but increasing the data and also implementing an algorithm that could accurately label the words in the audio files would really enhance this model and actually allow me to pinpoint specific accents, which I think is also a solvable problem. So that's my project. Are there any questions?